Motion. This lesson is about Class 9 Cbse. Physics. Chapter 8 Motion. Presented by Sparkling Bookworm. Speed, velocity and acceleration. Speed is the rate of change of distance or the distance traveled in unit time. It is a scalar quantity. The SI unit of speed is ms1. Speed equals distance traveled / time taken.
Assume you're standing at this point. Now, if your friend tells you there is a treasure pot 50 kilometers away from home, how long will you take to find it? Which direction will you go? It could be here, or maybe here. It is hard to know where exactly it is. You are only provided the distance, which is one-dimensional information. One-dimensional information like this is called a scalar quantity. Your question to him would be, which direction from home? When you are told that it's 50 kilometers in the northeast direction, you have the precise information of the location. This now becomes two-dimensional information, distance and direction. The treasure pot is over here. Two-dimensional information like this is called a vector quantity. Scalar quantities are one-dimensional and vector quantities are two-dimensional. Speed is a very good example of what we call in physics a scalar quantity, indicating only magnitude but not specifying any direction. So that's what scalar quantities are. Only magnitude but no direction. In the case of velocity, however, the direction is stated and that's why it is referred to as the vector quantity. A vector quantity involves not just the magnitude but also the direction. When you add directional information to speed, it becomes a vector quantity called velocity. The additional information makes it more specific. Temperature change, for example, is one-dimensional quantity. But when we specify rising or falling temperature, it is two-dimensional. If someone says that the temperature has changed by 2 degrees, we won't really know if it has increased or decreased. We will look at various scalar and vector quantities in the next few tutorials and for as long as we study physics. Speed, velocity, distance, displacement, mass, weight, force, acceleration.
An object travels 16 meters in 4s and then another 16 meters in 2s. What is the average speed of the object? Solution. Total distance traveled by the object equal to 16 meters plus 16 meters equal to 32 meters. Total time taken equals 4s plus 2s equals 6s. Average speed equals total distance traveled / total time taken. 32 meters / 6s equals 5.33 ms1. Therefore, the average speed of the object is 5.33 ms1. Problem 2. A sound is heard 5s later than the lightning is seen in the sky on a rainy day. Find the distance of location of lightning. Given the speed of sound equals 346 ms1. Solution. Speed equals distance / time. Distance equals speed, time equals 346, 5 equals 1730 m. Thus, the distance of location of lightning is 1730 m. Velocity. Velocity is the rate of change of displacement. It is the displacement in unit time. It is a vector quantity. The SI unit of velocity is ms1. Velocity equals displacement / time taken.
We have seen previously that speed is the amount of distance covered in a given amount of time. It's nothing but distance covered over the time taken to cover that distance. Simply put, it tells us how fast an object moves. Also, if we know the speed and the time taken to cover a distance, we can easily find the distance covered. So if I tell you that I traveled at a speed of 50 meters per second for 1 minute, can you tell me how much distance I covered? I am sure you've come up with the answer. I have covered a total distance of 3,000 meters. But if I covered 3,000 meters from this point, am I here or over there? You had no clue as to which direction I headed off. This tells us something interesting. Speed offers only the magnitude, making it what we call in physics a scalar quantity. It doesn't specify the direction. It just tells us how much ground is covered in unit time, regardless of the direction traveled. Scalar quantities have only magnitude and do not specify direction. Do you remember the difference between distance and displacement? Distance just tells us the distance covered, but displacement is distance with direction. Say the distance between towns A and B is 20 kilometers. So if we take a 50-kilometer route from point A to B like this, then the distance covered is 50 kilometers and the displacement is 20 kilometers north of point A. So speed does not tell us the direction. Is there anything that tells us the speed along with direction? Yes, it's velocity, which can be written as lowercase v. Let's see how it differs from speed. What if I tell you that I traveled north at a speed of 50 meters per second for 1 minute? Would you be able to tell me where I landed up? Yes, you would know I have covered a total distance of 3,000 meters and landed up at this point. Velocity is speed with direction of motion. As such, velocity is direction aware. So when you mention velocity, you must keep track of direction. Something like the car moved south at 55 miles per hour. If you do not mention the direction and just say the car moved at 55 miles per hour, you're not stating the velocity anymore. What you are stating is the speed. What do you think is the unit of measurement for velocity? The unit of measurement for velocity, just like speed, is meters per second. Now you might ask, why meters per second? The cars we drive indicate speed in miles per hour or kilometers per hour. So why is the unit for velocity meters per second? The established SI unit of measurement for velocity is meters per second. And SI stands for International System of Units. This helps everyone in the world adhere to one common style of measurement. Imagine the confusion created with different measures like miles and kilometers, gallons and liters, US gallons and imperial gallons, etc. Incidentally, speed and velocity are both measured in meters per second. But do you remember which one is a scalar quantity and which one is a vector quantity? Yes, speed is a scalar quantity and the velocity is a vector quantity as the direction is also specified. Now let me ask you an interesting question. What is average velocity? To make it a bit easier for you, let's look at the example we looked at in our first video on motion. You have to travel 20 kilometers up north. But because of the roadworks, you took an alternative path which totaled 50 kilometers and you took 2 hours to reach the destination. This was your path of travel. Let's make 2 columns here. One for average speed and another for average velocity. Do you remember how we calculated average speed? Yes, it is the total distance covered over the total time taken. So 50 over 2 will give us 25 kilometers per hour as the average speed. Now what will be the average velocity here? The average velocity depends only on the start and end points regardless of path taken. Do you remember we had learned about displacement? So the average velocity equals displacement over time. What is the displacement here? It's 20 kilometers up north. Distance with direction. So the average velocity will equal 20 kilometers over 2 hours, which will equal 10 kilometers per hour. That's the concept of average velocity. So if you think you've really understood this concept, here's a question for you. You are a Formula 1 race car driver. You had a great race and finished the 300 kilometers race in 1 hour and 40 minutes at number 1 position. What was your average velocity? Okay, if you didn't get it, let me give you a hint. This was your start point and finish line as well. They were both the same. You went around the track several times only to eventually finish at the same point where you started. So tell me now, what was your average velocity? First, can you tell me what your displacement is? You started and finished at the same point. So your displacement is 0. 0 divided by the time taken, which is 1 hour 40 minutes, equals 0. That puts your average velocity for the race today at 0 meters per second. If, however, you were trying to calculate the speed you drove at, that would be a different answer. Try and work it out. So now let me ask you another question. I was also in the race and you probably didn't notice me because I finished last. I took 3 hours to finish. What was my average velocity? That's correct. 0 again.
Speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. Speed with direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate average speed. Speed with direction. In case the velocity of the object is changing at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity equals initial velocity plus final velocity, /2. Mathematically, VOV equals U plus V, /2. Where VOV is the average velocity, U is the initial velocity and V is the final velocity of the object. Speed and velocity have the same units, that is, ms1 or m per second. Distinguish between speed and velocity. Speed. Speed is the distance traveled by an object in a given interval of time. Velocity. Velocity is the displacement shown by an object in a given interval of time. Speed equals distance / time. Velocity equals displacement / time. Speed is scalar quantity and has only magnitude. Velocity is vector quantity and has both magnitude and direction. Thank you. Please share, like and subscribe the channel.